All right. I ran out of time again. So, most iPhones can't seem to pick this up. At least when I've done it in class, the iPhones don't seem to do it, but the Droid things do. So, I don't know. I don't know if that means it's a better camera or a worse camera, but that's infrared light coming out there, and that's the type of light that they use in optical sensors. So it's not light that you can see with the naked eye, but it's light nonetheless. So nice little parlor trick there for the remote control. By the way, my Roku remote here has a slightly more powerful light. When I was in the house trying this out earlier, I usually do it at school, but I've never tried it at home. It was a little darker. I think the fluorescent lights in this garage are kind of fouling me up, but the thing is, yeah, doesn't look too impressive on camera, but it was pretty bright in the house. Alright, so for an optical sensor or a photoelectric sensor, your basic components are going to be a disc with slots or holes, a light emitting diode, and a photodiode. So another nice digital signal coming out of this, just like our Hall effect. It's a very good sensor. And one thing I'd like to mention, because light is so fast, I don't know what the speed of light is, it's like 86,000 miles per hour, something like that, whatever it is. Because light is so fast, this is actually, of the three, the most accurate triggering device. And when I made this little disc, I purposely put the holes kind of inboard. You notice there's 4 of them, so this would be how it would be set up in like an older 4-cylinder car with a distributor. There'd be 1 hole for each cylinder. On a more modern application, there would be, ooh, I'm getting on a lot of line here, a whole lot more holes. Okay, I thought this was going to be cooler, doing it on camera, but what I'm finding is the hole punch doesn't punch that well, and I'm not that uniform at spacing these holes, so that would make for a really, really lousy triggering device. But the point I'm getting at is, on a really accurate optical sensor, they'll actually have 2 rows of holes, and they'll have 2 LEDs underneath, and they'll have 2 photodiodes above. So one of them is making what they call a low resolution signal, and one of them is making what they call a high resolution signal. This thing would be making like a 0 resolution signal. But what they do with that high resolution signal, because this sensor is so accurate, they'll actually punch 360 holes, and then they have the ability to detect every single degree of rotation. So pretty much the best sensor you can have, but it's got a flaw. So if you've got a disc that's a couple inches around, and you punch 360 holes in it, they're going to be really tiny holes. Well, a film of oil is all it takes to block those holes up, then the light won't shine through, and the sensor doesn't work anymore. So when we had optical sensors in distributors, remember the distributor's a mechanical device, the shaft goes down into the engine, oil can get up the shaft, and there's a seal in there. If that seal goes bad, and oil gets up into the distributor, it will foul up that optical sensor. It was more common on the imports that ran the distributor sideways, sticking up the side of the head. As the distributors would get worn, oil would get in there, and they would stop sending the signal. So that was kind of common for a while on Nissans and Mitsubishis. They had some issues with those. There were certain Chryslers that ran that type of distributor. So you're not going to see the optical sensor everywhere. It's not quite as versatile as the other 2 sensors, just based on its requirement for being clean. It has to be safe and clean and tucked into a nice little place, like a distributor or inside a little housing. You can't stick this behind a crankshaft pulley where grease and gunk are going to get on it and water is going to splash on it, and road debris, etc. And also light. They don't want external light getting on this thing, so it's going to have to be in a dark location. But again, one of the better optical sensors. If it wasn't raining like crazy right now, I could actually take this camera out and I could pop the distributor cap off of my Fairlane, and I could show you inside there. That one's been converted from points to electronic ignition, and it's using an optical sensor, so I could show you that one, but it's raining right now, so maybe another time. All right, folks. Well, I hope you enjoyed our lesson on triggering devices. So, magnetic, Hall effect, and optical. I'm going to give you some questions to answer based on what you saw here. And obviously, the internet's a wonderful thing. You can Google any of this information and probably find more than you ever wanted to know. So, hope you enjoyed the video. Feeling a little bit more comfortable standing in front of the camera now. Again, still miss you guys. Still wish we were in class together having fun and learning together. But we'll get through this. So, talk to you soon.